everyone. We are now live. Welcome to the 10th Meetup, Feature Store Meetup, the first of the 2022. So welcome back for those who know us, and welcome for the first time if you're new here. Today we have a very exciting presentation from a new player in the Feature Store space. Before we get started, just a few reminders. We are recording this meetup, so you'll be able to rewatch it on the featurestore.org website later on. And we have a Q&A session immediately after the presentation. So please use the Q&A button to send us questions. Jordan will be answering as many questions as we can get today. Now I'll pass it on to Jim.
Great. Hi. So I'm Jim. Let me just try and see if this works because I'm on an Ubuntu laptop. I hope we're good to go. Yes? We're good, Natalia. Okay, I assume. So hi, I'm Jim, and I'm co-organizer of this meetup, the Feature Store Global Meetup, and I work with Hopsworks. And today, what number meeting is this? This is the 10th meetup. All right, so we've had 10 meetups, and we had a big summit in October. And so that's a nice round number, 2 digits. And today we're really delighted to have a new player on the stage. It's Continual. And we have Jordan Volz, who's the director of field engineering there. And Continual, a bunch of them came from Cloudera. So they have a good history in the space, in the data space. You know, we're looking at the kind of the modern data stack, I think, is part of the kind of the take on feature stores, which will be very interesting to hear. And you can call that building a SQL-centric feature store is another way of looking at it. And he's the only talk we have today, and we'll have Q&A at the end. Now, as Natalia said, there's a Q&A button at the bottom in Zoom. Please press that. The chat button, if you press it, you might send it to the panelists, you might send it to all. So it's better to just ask your questions on the Q&A button. A couple of things before we get started. We are a community. You can apply to speak at this meetup. You can go to featurestore.org and there's a link there for how to apply to speak. We have a Slack channel. Please go in there. You can go and ask questions now and people will ask them. Jordan might hop in there. And there'll be a bunch of other people in the community who will be in there. And I'd just like to say before we get going, we did a redesign of the website. So please give us some feedback on that. And you can do it in the Slack. So featurestore.org, it's a little bit more centric around the community. So for the people who've talked at the meetups, the people who've talked at the summit, the other thing is the videos from the summit are live. And I don't know if everyone has seen them. So I'm just going to just show you briefly. So this is if you go to featurestore.org/featurestore summit videos, you can Google it, just Feature Summit videos. You can see tons of videos from the summit back in October. Now with that, I got to hand over to Jordan. And Jordan, you said 30 minutes, maybe a little bit more. Ask your questions down below. Over to you, Jordan. I've stopped sharing my screen, sorry. So
thank you. I should have shared mine. Can you see it?
Yeah, we can see it. You're great. Perfect.
All right, awesome. Thank you. So great introduction. I'll be talking today about building a SQL-centric feature store. And part of that will involve how would you generally do this, and then we'll also talk about what we've done at Continual a bit as well. Brief background on myself. Currently, I'm the director of field engineering at Continual. At Continual, we're really focused on bringing operational AI or operational ML to the cloud data warehouse. So I'll talk about that a little bit more later in the presentation. Prior to Continual, I've worked at companies like Cloudera and Dataiku, and HP Autonomy and Epic. I've had a variety of different roles. I've been everything from a software engineer, actually writing code and creating product, to working more as a systems architect or data scientist, working on architecture or the actual data itself. So I feel like I generally seem to have kind of a pretty unique view on things, as I've worn a lot of different hats and kind of seen how the system operates with a lot of different people who actually are involved in it. And you can follow me on Twitter at Jordan_Volz, or at LinkedIn, which is just Jordan Volz for anybody who's interested. So the first part, I wanted to dive into why SQL. So I think if you look at the feature store market, A lot of feature stores out there are kind of more code-based feature stores. So even I think proposing that we focus on building like a SQL-centric feature store is maybe something that needs a little bit of justification. So I'm going to spend a little bit of time at the front here trying to justify that viewpoint. First slide here is a very, very brief and selective history of the data platform. So coming from a background like Cloudera, I'm particularly interested in the data platform space. And what you see is, 1970, Edgar F. Codd wrote a very influential paper, which pretty much, laid the foundation for RDBMS. And it took a little bit of time for that to really get picked up and commercialized. But by the 80s, you had a lot of companies doing that, like IBM, Oracle, and Microsoft. And then into, the 90s, companies like Teradata, SAP came around and started having their own take on it. So you had several decades there where the relational model was really the go-to model for data platforms. And, that was really the status quo. Things started to change in the 2000s. Lots of reasons you could point to. I think the main instigator is usually that, internet towards the end of the 90s really became like a mainstream thing. Everybody was on it. So you now have advent of like a ton of user-generated content, which means the amount of data an average company could possibly collect and care about really grew exponentially, or started to grow exponentially during this phase. So if you go back and look at your older database systems, you can look at those and say like, well, these aren't really built for terabytes or petabytes of data. Like, what am I supposed to do if I want to analyze this data? So out of that, we got big data, the big data ecosystem, or the big data distributed SQL, NoSQL type tools. In this, you'd place things like Hadoop, Vertica, MongoDB. So I think a lot of technology in this time was really great at handling that scale question. Ease of use was always a question, like, were these things easy to use? Could people effectively build solutions on top of them? So that lasted about a decade or so. And in the 2010s, we, of course, saw the advent of cloud technology. So, cloud technology, one of the great things about it is you don't really need to maintain a lot of the things that you're consuming in the cloud. So why not data as well, right? I can spin up a cloud data warehouse. I can run it on Snowflake or Amazon or Google, or Microsoft or Databricks. Everybody kind of has their own flavor of data warehousing in the cloud, and they're maintaining the stack, and I now can just leverage that. I, of course, have to get my data there in some way. But once it's there, it makes it very easy for me to start analyzing the data. So today, this is in my mind at least, the very latest and greatest way that you would build out a data platform. If you came to me and said, Jordan, it's 2022, I'm giving you a team of people, we have no infrastructure, let's build something to deal with our data, I would probably say, well, we should start with the cloud data warehouse. I think a lot of these older approaches don't make sense if you're starting from scratch. And, there's definitely been a lot of communication out there in the technology world about how you migrate from older systems into the cloud and how do you get stuff into the cloud data warehouse and stuff like that. So, this is hopefully not a shocking conclusion here that, here in 2022, this is really kind of the standard. This is, the thing to beat right now is the cloud data warehouse. So from the cloud data warehouse, there really evolves an ecosystem of tooling to support workloads on the cloud data warehouse. And, collectively, this is kind of known as the modern data stack. If you haven't heard that term before, this is the first time I'm introducing it. I'll provide some examples. But the idea is like, let's try to take all the things you need to do with your data and make that very easy. So, the first thing is, well, we need a data warehouse in the first place. So, these have all been around a decade or more by now. BigQuery, Snowflake, Redshift were all around by 2012. And then we start looking at business intelligence tools. Chartio and Looker were the first ones who are really focused on the cloud data warehouse. There have been more that have come out since then. I think Redash was acquired last year by Databricks, if I recall correctly. So we've already seen some consolidation in the market. 5-trans segment stitch, these tools are focused more on getting your data into the cloud data warehouse. So of course, as the cloud data warehouse picks up in popularity, you're going to have tools come out which are focused primarily on helping you get your data into the cloud data warehouse quickly and smoothly. If anybody has ever done this without these tools, you probably realize that just working with APIs and other things can get quite cumbersome after a certain amount of time. So there's certainly a vendor need here. And then 2016, we see DBT, Dataform, is a tool that came, I think in 2017 or so, or 2018 afterwards. And these are transformation tools built essentially to work on top of the cloud data warehouse. Dataform has since been acquired by Google. DBT has kind of stood out now as kind of the lone tool in this space, and definitely the winner by I think just about everybody's estimation on like what's the best transformation tool for the modern data stack. And like since then you've seen more innovation, but I'd say about like 2016 you had like a pretty good core of technologies. DBT of course was new and has evolved over time, but Census and HighTouch are focused on getting your data out of your data warehouse and back into your tools that your users use. So for example, I may do a bunch of analysis on my data and then want those insights to bubble into Salesforce so my sales team can understand customers or opportunities better. And those tools are geared toward those types of problems. And then as people adopt this technology, you need, more sophisticated tooling around like data governance and data observability and stuff like that. So tools like Monte Carlo Data and Stemma and others in that vein have continued to come out. So, there continues to be just a lot of evolution as the stack evolves and grows. But the gist of it is that, I think if you're a cloud savvy company today, you're probably maybe not adopting the entire modern data stack, but you definitely have several components of it. You probably are using the cloud data warehouse. You probably have a tool like DBT that your data workers are using to write their transformations on top of that cloud data warehouse. You probably have several pieces of technology around that as well, like maybe a reverse ETL tool or a data integration tool. And on the left here are a couple of different bullets that I think do a good job of like summarizing what does it mean for a piece of technology to be in the modern data stack. And I think it's things like you have to be cloud native, you have to be easy to use. So we're really trying to lower the barrier of entry as much as possible. People don't want to, install and maintain technology. They want to work on their data problems. So we need software that you can just kind of get started with, like sign up for an account and get started with today. The one I've highlighted here is that there is a super huge focus on everything being SQL-centric. And the fact that we're centered around a cloud data warehouse hopefully makes that not a surprising conclusion, but that I think is an important distinction in the context of this talk about feature stores, which is, we're building a new modern data platform. All these tools are really working with a SQL language. And so like you also want to kind of be compliant with that approach. And a lot of the idea here is that by using SQL, you are democratizing your data workflows, right? So if I create a new great tool and, when I was in school, I had learned functional programming and we had learned Haskell as a language. And I think Haskell is a pretty cool language to use. I don't get a lot of use of it day to day, but I could say like, hey, I want to build something with Haskell and this will be super awesome. What won't be super awesome is when like I try to collaborate with other people because like nobody out there knows how to use Haskell. So this, it's true of other things in the data technology as well, right? Like more people know SQL than know Python. So if I make a tool that requires that Python or requires that Java, there's a larger barrier of entry. So you essentially are trying to dial that back as much as possible and give a very simple tool that everybody can work with. And SQL, I think in my mind, is that tool for data. I don't think there is a simpler tool for data access than SQL currently. That could be disrupted in the future. I think many people have tried. I haven't seen one succeed yet, but to date, I think SQL is kind of the common language across data workers often. So, the main conclusion in this intro is that, here's a quote, and I don't know who said this, meet people where they are, not where you want them to be, someone wise. It wasn't me. This often seems like a truism, right? Because like, how could you meet someone at a place where they aren't? But, in the context of this introduction, if everybody's like kind of adopting this modern data platform, we shouldn't be trying to impose on you a paradigm that is not what people are building towards, right? So you're trying to build tooling around their data platforms. You notice the trend that like, hey, everybody is going and building this modern data stack. Everybody is building around a cloud data warehouse. So let's try to build a tool that makes your life as easy as possible, instead of forcing you to go back in time and work on a traditional RDBMS or working on a big data stack or something like that. I don't think people generally love like debugging Spark jobs and things like that. So let's try to remove that from the equation as we move forward into the future. So the next part we can ask, does this work, right? You can say, cool, I buy your motivation for having a SQL-centric feature store. Can you get it to actually work? And I wrote a blog, I think this was like August or September timeframe, on our company website. So there's a link here if you want to read it. But I had spelled out some things that I thought were, kind of critical for feature stores to have. So things like being able to transform data, supporting both online and offline mode, having entity resolution, lineage of features, point in time correctness, model encapsulation, data drift. I think if you're building a feature store, these are kind of the main things you should be considering and have a solution for. So we can in turn look at these and say, like, can you do these with a SQL-centric feature store? So transformations. Someone at some point in 2021 had sent me this meme, which I found kind of funny, but it also kind of applies to my view of kind of ML platforms. And so like the gist here is like, a lot of people are out there think like, hey, Python is great. We need to use Python for a lot of, machine learning type work. So that's like the guy in the middle. And then, as you go on and you get more experience, you kind of realize that, most things you can probably just use SQL for. And I think, for most intents and purposes, SQL is perfectly fine for just about like 95% of the transformations you actually need to do. So there may be some more obscure stuff where you may need a Python library. I think a lot of these are like text-based processing of data and stuff like that, which, in SQL, there may be less standard ways to do it. And maybe you don't want to spend your time writing like bagging algorithms in SQL. But, there's a lot of external functionality in SQL engines these days. So like, for example, if you're a Snowflake customer, you could use Snowpark, and you could write an external function that would bring in your Python library of choice and run your data through that to create, a new column or whatever. So I think you can stay within the SQL world and still have escape hatches out to the things that are needed. So I don't really buy the argument that I need Python because I can't do my transformations in SQL. I think that is generally not a true statement. But also DBT exists, right? So DBT is something that I think, over the past 3 years or so has really taken a lot of data teams by storm. I talked to a lot of people of a lot of different profiles, data scientists, data engineers, data analysts, analytic engineers. Like, it seems just like everybody is using DBT or everybody's in the process of adopting DBT. I see a lot of people who were using DBT at their former company, move companies, and they convince everybody they need to start using DBT. So I think this is also a compelling argument that, like, if DBT is becoming kind of the transformation standard, and I think it definitely is in the modern data stack, and I think it's even becoming a transformation standard outside of that as well, that your question should be like, can you work with DBT? And the, DBT is handling the transformations, like, that's fine. Like, we don't actually care about the transformations as much anymore. Those are just now tables in your data warehouse. And so can we just integrate with DBT? So, hold that thought. We'll talk about this a little bit more in the next section, but I think this is like further evidence that, like, if DBT is being used with, all over the place for transformations, like, maybe this Python approach for transformation, so actually isn't needed that much. So offline support. I think offline support in a SQL-centric feature store should hopefully make a lot of sense. So essentially, users can define features as SQL statements, and those are going to manifest themselves as tables or views in your cloud data warehouse, right? So the nice thing about this is that we don't actually need to copy your data into the feature store itself. We could just have it live in the cloud data warehouse. And an objection I've heard from a lot of people in feature stores is they don't like copying their data. A non-trivial number of feature store solutions out there kind of maintain their own copy of your data, and this allows you to be very nimble and just define new definitions in the existing feature store. And when you need that feature, you then just go to your cloud data warehouse and you say, execute this query and give me the data, and they do that. So I think this is a pretty compelling argument. This approach doesn't work for low latency use cases, though, right? So if I want online scoring, if I want like discrete serving of features, your data warehouse is generally not going to work, right? So your cloud data warehouse, it could serve as your offline feature store. We still need an approach here for your online feature store, right? So, I had said the feature store has to do online and offline, and so we need some kind of a solution up here. If we look at what are the main considerations, I would say they're kind of twofold. One is, can we serve up features discretely in a very fast, like sub-second or even, sub 100 millisecond response time. Obviously, if my cloud data warehouse is tasked with that, we're not going to run a SQL query and get a response back in under a second. And in most use cases, especially, in the current paradigm of cloud data warehousing, where you're separating compute and storage, and we don't even know if our compute is up or not. It could take 15 seconds or so to even spin up the compute so we can run a query in the first place. So we need something else for this online feature store. So the feature serving is key. And then also kind of this idea of do you need to do transformations in your online feature store or not? So I think depending on your use case, the answer to that could be yes or no. And then a third thing is around this, sync process, which I'll talk about more in the next slide. But what are your freshness requirements? So how in sync do your online and offline feature stores need to be? And I know there's been a lot of writing about high-tech companies using feature stores out there. And if you read between the lines on some of these, I think this is a process that a lot of them kind of tend to brush under the rug quite a bit, where you could look at this and say well, these have to be exactly the same in terms of freshness. I want exactly the same data in my online and offline feature stores, but I think that's actually not the case in a lot of these systems. So, I think your two main options here are you're either doing a push from your offline feature store, which would be your cloud data warehouse, into your online feature store, or you're doing essentially a stream into your online feature store, from your online feature store into your offline feature store. Those are the main two ways you could solve this problem, right? Why would you use one over the other? I think your two main use cases here is that if you don't have really strict freshness requirements on your data in your online feature store, I would say the simplest thing to do would just be to periodically do a batch sync from your offline feature store into your online feature store. You probably then don't even need to worry about streaming data directly into your online feature store. And the real reason you have an online feature store is just quick serving of features to downstream downstream applications, right? So that I think is probably in reality a lot of the requirements for a lot of online use cases, where you don't necessarily need the latest data in the system, and the reason the reason that is true is because a lot of these also deal with model encapsulation, where we are actually going to be getting the latest data from the client, right? So, if I'm serving up predictions to a mobile application, I may be doing something like doing a prediction based on the user's location, but whatever is in the online feature store is going to be less fresh than the application in the client's phone, which can just use GPS and pass those in as overrides into my into the feature store, right? So I think that's a compelling argument for a lot of use cases that I've seen. So it's, there's a lot of use cases I believe where this freshness requirement is not super strict, and you could say we're doing a sync every hour, or twice a day or once a day or something, and as long as my features here are fresh within that time span, I'm okay. If it's more than that, the application knows they need to pass in overrides for more relevant features. The other use case is, if you needed essentially the freshest features possible, what you'd probably do in that case is just stream features directly into your online feature store and then periodically sync those into your offline feature store. So, typically your offline feature store is going to be where you're building your training data sets, where you're building your models on top of the data. So we do need to update that. We can't just ignore that entirely. But we may care more about the freshness of the online feature store than we do the offline feature store. So in that case, we now would revert back to a streaming type of use case where we're streaming into an online feature store, and then we can serve those up instantly. So this does add a lot of complexity because we now need to actually do transformations in the online feature store, right? In the first use case, I actually had removed the need to do transformations on the online feature store because those are just done in the offline feature store and you push them up into the online feature store. If you're in a streaming world, you would then need to do your transformations in your online feature store as well. Thankfully, though, a lot of these technologies are pretty advanced these days and do support SQL style interfaces into their transformations of the stream itself. So, Kafka tends to be a very popular streaming technology. That is something that has its own SQL flavor, KSQL, and you can just use it and write your SQL on top of Kafka. So I think even in kind of this more challenging, streaming based real time use case, there's even a way forward to just say hey, we defined all these things in SQL, we can continue to just operate SQL on top of it, and everything works. There's a third option here, which I consider to be definitely the most challenging option, but I think the third option here is if you want to embed, your third use case here would be just embedding a model inside of a stream itself. And that is actually in my book, not a feature store. That's a use case that's not really relevant to the feature store because the feature store isn't really being used there. But I think a lot of these real-time use cases, when I've talked to people about them, we kind of get to the decision of don't you just want to build your, if you're really trying to get the lowest latency possible, I don't want to be going to an API to get predictions. I want to just embed my model in my application and run that as part of the streaming framework. And you're never going to be lower latency than that. So, again, there's a lot of factors to consider here, but I think, that's a pretty valid one as well. I'll kind of skip over the other things, the net of the other requirements that I brought up as can SQL work is they all work, and there's really not a lot of difference between how you would do it versus SQL versus how you would do it versus non-SQL. The entity resolution, I think, is arguably a lot better for SQL users than non-SQL users. So if you're not familiar with entity resolution, this is something that's actually been getting a lot of traction in the last half a year or so, and the tech circles. But the idea is instead of working with base tables and all of that, can I just work with business objects? So here's an example where I could just say give me customers and filter out by the customer plan equals free, and I'm working with a system that knows what is the SQL that I have to write in order to actually do that. And over here, this now involves two different joins and a group and all these other things. So the net of it is it allows users to work with the data in a lot easier fashion, right? Because I don't have to know what are the 3 or 4 tables involved here and what are the filter requirements to make these joins happen. I just know that I want to know what customers have a free plan. And that's a pretty simple command right over here. And I'm now working with a system that's entity aware, and it figures all that out for me. So I think this is especially very cool in the feature set world where you can do a similar type of thing with feature definitions. So the others kind of work. And then the third part here is, what does this look like in the machine learning system? So if you look at the modern data stack, kind of like going back to our modern data stack diagram, on the left here, we have the data science hierarchy of needs, which I'm sure most people here have seen before, but the idea is like each stage relies on the one before it. And if I go to the modern data stack, we can find tools for everything in there, except we don't really have a tool that has really bought into this mindset on the like AI or the ML level. And I think a key goal, if you're in this ecosystem, is to empower people who understand your business, right? So as you go up your data science hierarchy of needs, you're, inevitably increasing complexity of your workloads, right? Like, data transformation is more challenging than data storage. Data science is harder than everything else. So you're always getting increasing complexity, but when you look at your user profiles, you always have more of people on lower levels, right? Like I have more people who can do data transformations than I have people who can do data science. So if I can boil down my data science workflow into just writing like SQL, then I've actually enabled a company to have a lot more people build ML workflows. And that's essentially the philosophy at Continual that we're trying to hone in on. So you could say like, all right, I'm in the modern data stack. I buy into the SQL-oriented feature store. Let me just go use it. You could certainly do that. And here is like Uber system that just shows kind of like the higher level components you need, and your feature store is here in red. And then what you realize is there's a lot of other stuff that needs to be built. So we're in the modern data stack. We generally don't want to spend a lot of time building our own stuff. We want to just use stuff that exists and make it work. And the reality is, like in the ML category, you just don't have stuff that operates in that way. So you could say, like, let's go build an existing machine learning platform. And I have worked for and built a lot of, or partnered with a lot of the existing platforms out there. And no one really fits into this modern data stack very well either. So, in terms of this, this talk, most of the existing ML platforms out there are really code-based. They're expecting people are going to come in and write code to some extent. And then, of course, in the modern data stack, everything should be SQL focused. There's a lot of other reasons why they don't work as well, but I'm focusing on the SQL one. I think the SAS one is also very compelling. A lot of the existing platforms were built during the big data era, right? So they were built around things like Hadoop, things like NoSQL databases. And they often are built with the expectation that people are going to install and maintain the system. They're not built with this new modern data stack philosophy that, like, hey, everything is SaaS, everything is SQL, everything's easy to use, everything just works. And I think that's a big problem for modern data teams who are looking for the lowest level of their own time and commitment to maintain systems. They want to focus on solving problems, on working with the data. And that's just really not possible with a lot of these more complex tools out there. So for Continual, I don't want to get too much into a pitch here, so I just thought I'd just throw a few slides because often people are interested in, like, what are you guys actually working on? So we're really, leveraging, or we're pitching ourselves to be the first ML platform co-designed with the modern data stack. So you should be able to enable your teams, kind of regardless of their profile, to come in, start working on top of their cloud data warehouse, start building out ML workflows that help to drive business value for your company. So we fit with your current stack. We adhere to all of these key tenets of the modern data stack, like being cloud native, everything SQL focused. We're very much focused on automation and operationalization of workloads. That was one of the key things that we were founded on. And we just integrate directly with your cloud data warehouse. So everything is super easy behind the scenes. There's three key components that we're providing. One is this SQL-oriented feature store. So the idea is you can come in and you can define all your features in SQL statements. The second one is we have a declarative AI engine. There's kind of two pieces of that. One is we're declarative, and one is that we have an AutoML engine. So I can't expect, a data engineer to come in and like build their own models, right? So we need an auto ML engine that enables you to quickly connect to features in the system, build models, and maintain those over time. And that, happens through our auto ML engine, but it's also driven by this declarative approach, which, through a configuration file, you can tell us exactly what your workflow consists of, and we can then run it and maintain that over time. And also update your model as new data comes in, and update predictions as new data comes in, and all of that. And then the third part is this machine learning ops, or explainable AI component. So again, this is kind of just naturally filling out the data science workflow. As you're building models and predictions, you want to start to analyze those. You want to understand like how are your models performing over time, how are your predictions performing over time. Is there data drift happening in the system as your features are changing with new data coming into your data warehouse or whatever. So that's a key thing to build trust in the system, and then also to provide more advanced capability for users downstream as well. And we think, going back to that Uber diagram, we think it's key that you're trying to fill in as many of those boxes as possible, right? So, everything you don't do, you're just giving a burden to customers to go and have to build it out themselves. So how does it work? Very simply, we connect your cloud data warehouse. You define features and models with a declarative SQL experience, and then we maintain that over time for you. So you can come in, you can tell us exactly what your features are, what your models are, what are the transformations in them. We actually do have entities in the system. So models connect to entities, and then the entities understand how to build out the training data sets amongst all the entities that you're involving in a particular model. I think this is a key capability that really enables a lot of users to come in and start making use of the system. Because I can very easily build out models that involve 10, 15, 20 different tables. And if I have to understand the relationships between all of those, anytime I want to build a model, it's a huge pain. But if I just say hey, give me the customers, give me products, give me sales, those are my three entities, the system then can go and build that for me. And that's, I think, great automation. And, essentially you're inheriting other people's intelligence in the system of your company's data sets. We also have dbt integration. So, early on, we had looked at what was happening, and we kind of realized a lot of people were standardizing on dbt as their transformation layer. So a lot of people are in this, data engineering bucket of using dbt as their main tool. So we thought, a lot of feature store tools out there kind of force you to duplicate your efforts, right? So you may have a data engineering tool, and then you're using it and you're maintaining your pipelines, maybe an Airflow or something else. And then you come to your feature store, and you essentially have to redo a lot of that work when you're defining features in the system. So with the dbt integration, you can actually just use Continual and run it on top of a dbt project, and we will register those as assets in Continual. So, essentially dbt is where you're doing your transformations and you're maintaining those, and then those transformations get registered in Continual. So Continual is then aware of them, and you can start linking them into entities and building models off of them and all of that. And another key thing, I think this is probably the last slide, is that we are also really working for that. I said we're operational AI. What is operational AI? Operational AI really means that we're giving you a simple path to production for your workload. So, early on, we wanted to mirror, a very Git-like approach. So, dbt has also been designed in a similar fashion where, early on, they were positioning themselves as, making data analysts feel like a software engineer. And it's a very simple way to use dbt, and also do more complex things like maintain environments and maintain isolation between environments and dbt. So similarly in Continual, we have environments, we hook up We hook up with DBT as well. So like in DBT, you can be working your DBT environments, and then those correspond to different environments in Continual. And the declarative approach of Continual actually makes it super easy for you to drive all of your CI/CD pipelines. So you can then hook those into Git and have everything driven off of like PRs and things that are happening in Git, like just like you would if you were a software engineer. So now your workflow becomes, if I want to add new features into one of my models, I edit my configuration file, I commit it into Git, create a PR, someone reviews it, they approve it, and then the system pushes all that into the production environment. So behind the scenes, we have all that worked out. So that's kind of the quick spiel on Continual. I'll point out we're now in open beta. So we came out of stealth last summer. We came out of closed beta right before the holidays. So if you want to come try it out, you can come to continual.ai, and we have a free trial currently, so you can sign up and take it for a test drive. If you are interested in just like looking at a demo, I didn't want to really do a demo here. I always feel like meetups and demos kind of clash, but we do have a public demo every other Wednesday. So if you go to continual.ai, you can sign up for the next session, which I believe is next Wednesday.
Brilliant. Thanks, Jordan. Very interesting and great to see you making progress and putting your stuff out there so people can try it, which is a very, very important step to do in your journey. So we have a bunch of questions. I have a few questions as well, but we'll take, of course, we have the community first. The first one is anonymous, which, whatever, you can ask anonymous. They're being nice anonymously, but they're basically asking about your DSL. So you have this domain-specific language, which you presented, which was this get entity.
So that actually
you said basically saying you need a driver to render that. I mean, you're obviously, it's a DSL, so you're processing it and spitting out SQL.
Yeah. So that actually wasn't a continual thing. That was an example I found online of entities being used for SQL. So that is actually like not in the continual product, but that was just to highlight like what an entity would be. So.
Okay.
And how it boils down in Continual is like when you define a model, you essentially just link the columns in your model definition into entities in the system.
Yeah.
And then when you're registering feature sets, you just tell us as part of the configuration which entity that is in. So those in Continual, it's all just a configuration-based approach. It's not like you're actually writing entity-based SQL statements, but like I understand the confusion. The image I did use. Yeah, it's a YAML-based approach in Continual. The image I used was not the best in terms of that. So I apologize.
Just follow on that, right? Because I'm an old SQL guy. I worked at MySQL back in the day, and I did my courses on entity. When you go to university, you do your ER diagrams, entity relation diagrams, and then you get into tables. There's no entities. It's foreign key. It's foreign keys. It's primary keys.
Yeah.
So why do we need entities in feature stores? Because anybody who writes database code doesn't write entities. The abstraction doesn't exist. We have foreign keys and primary keys.
Right, exactly. I think there's maybe a good argument today that entities should be made kind of more as a first-class citizen within the data warehousing technology itself. But in my mind, the ease of me going into my company's data warehouse and saying, I want to know like all customers who signed up in the past week. Like that information is something like I, as just someone who's like in marketing or sales or whatever, like I can ask that question. Sure. I can't write that SQL. So for me to get that information, I have to then go to like a data analyst and say like, can you give me all customers who signed up in the last week who like also are using this product?
We have views in databases for that, right?
We do it well. Some people do. Yeah, some people do. In general,
we could go on about this forever. Let's let's move on. Sorry. The next question is from Ana Paul Santos Delfino. Great name. What about the costs? So this is the build buy argument. To build your own SQL store, I don't know, Kubernetes feature store, which is cheaper. In your case, you're not building or using Kubernetes. It's a SaaS platform, right? But
right.
What's your take on the build buy kind of argument right now? Are feature stores, let me put it another way, are feature stores a mature enough product now that people should just buy and stop building? Have we come that far?
Yeah, I think so. I think if you
Okay.
go out there and you look at the market, I mean, there's definitely different approaches. Like Tecton, you know, they're the old Uber guys. You know, they're focused more on streaming. Continual's focused more on data warehousing. You have kind of different. I think you have enough different takes on it that whatever is your priority at your company, there's probably someone out there who like very much aligns with your worldview. And these things take years to build. So in my mind, like the build question is like, do you have a team of like 5 or 10 engineers who you want to build this over the course of the next year or 2 years? And I just don't know why you would do that when you could just go buy something.
Great. Another question from, looks like Constantine, but I'm not so good at my Cyrillic. Do you do versioning? Do you have versioning support? So if you're doing dev, you know, like staging prod, how do we do an upgrade from one version to another? And how's your thinking on that?
Yeah, there is versioning support. So behind the scenes, everything is versioned. And you know, if you go into the continual product, you'll see like, you know, every time a model is created or batch predictions are created, things are versioned. Like batch prediction snapshot the prediction at the actual time that it was made, so you know like all the features at the actual prediction time. So yeah, versioning is an important aspect of this. I wouldn't, you know, like I didn't include that on my like list of things you need for a feature store, but I would say like that's certainly a capability or like, you know, something a feature store needs to provide. So
well, you have 2 types of versioning, right? You have schema versioning, and then you have the actual data versioning that you mentioned there. So what's your take on schema versioning? So you have your feature set and you've made a breaking schema change. So the versus data versioning, which is, you know, using time travel and so on.
Yeah, the feature store should handle the schema versioning. And, you know, when you're looking at Continual, it's more than just a feature store, right? Like we have to version your models, we have to version like essentially everything that's happening in the system. And then the data versioning, I think, is something you hopefully want to be able to push down into your data platform. So, you know, if you're working on Snowflake, Snowflake has some time travel capability. And I think they do like 30 days for free, and then you can pay for more or something. I'm not a Snowflake rep, so, you know, talk to your Snowflake team for the specifics on that. And then dbt actually does snapshotting as well. So, you know, in my experience at dbt, snapshotting is kind of good if you don't have anything else, but can probably be improved in the future. So it'll be interesting to see like if dbt ends up being this like vendor neutral way to really snapshot like all your data. And that makes it super cool for tools like us who are trying to build on top of your like, you know, generic non-vendor data warehouse to then have like one snapshotting method that we can use across all the different platforms.
Cool. I have a question now. I think someone answered your question. I'm going to get my one in first. So you made a comment that you should meet your users where they are, not where you would like them to be. And from my perspective, it looks like your users are not data scientists. So do you think we don't need them? Are they a redundant, species out there in the data world? Can an ML engineer kind of do it all and auto ML your way to predictive performant models?
Yeah, so I think over time the answer to that is yes, right? So I think over time, like, you know, how many times do you need to solve customer churn in your lifetime before you realize that you don't need to like do it by hand anymore? So like, you know, I think there's one that like use cases all become well known over time, and 2, the auto ML technology is always getting better. So I think it over time is harder and harder for data scientists to beat an ML model, or it's harder for them to justify the time they have to spend to beat an auto ML model when it takes an auto ML system like an hour or 2 to create a model, and it may take you like weeks to like manually like do all this feature engineering and stuff. So, you know, I think over time that like manual capability that we've come to know as data science, there's not as big
there's 2 parts, right? There's the training of models and model architectures, but then there's the feature engineering. So, right. So, you know, so the feature engineering is slightly different, right? So, you know, if I'm using SQL to do, you use the term transformations, but you've also aggregations, and now we've embeddings are incredibly powerful. SQL isn't there yet, right? So how, you know, like, what's your take on kind of like there's a lot of areas like NLP we're kind of, you know, revolutionizing a lot of stuff, and do you think they're kind of outside the feature store use case, or You know.
So I think the two main places for data scientists in the future will be, one is the feature transformation thing you were just talking about, and then the second one is understanding the machine learning process, because there's a lot of really nuanced ways about working, like even with an AutoML system, like working with an AutoML system. It's a lot about asking the right question, and understanding how the system is going to respond to that question, which in my experience, other data workers, like a data analyst or data engineer, might not know like how to ask the customer churn question correctly. And in a lot of cases, you don't have a table. Like when I go to solve my customer churn use case, like at a new company, they're not going to have a table that says like, here's my churn column, true or false, right? They need to create that. And that in and of itself is usually a data science problem. So like that's the feature engineering of like asking the right question. And then the back end is like understanding that like, well, 95% of our customers don't churn. So this is an imbalanced data problem. If I just throw it into an AutoML system, it may try to optimize on accuracy. It's going to decide the best model is just deciding that nobody ever churns. It's right 95% of the time, but that's actually a garbage model for our business to use. So you need data scientists to kind of like oversee that process and understand like what are the knobs that they can start to pull to get better results.
Yeah, I definitely agree that particularly evaluation of models and evaluating against different slices of data for different maybe groups who could be biased against a model is massively important. And me personally, I don't think data engineers can do it. I know enough about the space, but let's go on to next. We have more questions. So David, and we'll wrap up before the top of the hour, of course. David Yakatilaka, are you considering DBT server for entity resolution?
Yeah, so we are looking a lot more into further integration with DBT. So then that's both DBT Core and DBT Cloud. So I think as you see us advancing throughout the year, you'll see more integrations happening in that space.
Great. Bo Parman, where do you envision your top use cases will start shaping up going forward?
Yeah, so I mean, initially, as I said, we came out of stealth over the summer, and so we've been working with clients now for about half a year. We're seeing a lot of people come to us with what I would call kind of like mission critical use cases. So this is stuff around understanding your customers, understanding your sales, projecting sales, understanding churn, like understanding which prospects are going to turn into customers, understanding the lifetime value of your customers. So a lot of these are tabular in nature, right? Like all of this data is being generated and stored as tables in your data warehouse. So, over time, we hope to open it up into more exotic uses. So like NLP, like audio, images and stuff will be awesome. But there's always a question of like, how much can you do in your cloud data warehouse, right? Like, are images best stored in a database, right? Like historically, that has not been the case. I know Snowflake would love it if they could store all your data in Snowflake, and maybe we'll have compelling ways to do that in the future. But to date, some of these use cases that are kind of more exotic and more cutting edge kind of don't really, the data doesn't live in your data warehouse today. So I don't feel like you need to force it in there just to make it work.
Great. So Greg Throne is he's throwing one in the works, a spanner in here. He's saying you're not talking too much about the downsides of SQL being SQL based, and what are the risks that concern you? How will SQL handle things like embedding creation, semi-structured, unstructured data transformations?
Yeah. So I think most of the cloud data warehouses that I know of, they handle unstructured data pretty well. I've certainly done some unstructured use cases on top of them. They've been okay. So I haven't had any real problems with that. Downsides, I think, downsides to it, I think the main downside is you have less enthusiasm from your data science team on going like a pure cloud data warehouse SQL approach. They like to use Python, they like to use notebooks. So if you have an existing data science team, which has, if you're rocking 20 or more data scientists, it might be hard to convince some of them that like this is a new approach for them. But I think it's also perfectly okay to offer different tools to data scientists and like data engineers and data analysts, because we are seeing that Going down the stack and going to your lower level data workers, they're a lot more comfortable in this field, and like they don't want to start building out TensorFlow architecture and stuff like that.
Sure. So we got another one, Mike Moran, and he's moving further down in your platform. So you didn't actually say, do you have a model registry, I think, and a model serving? Do you do that? Do you go that far? You didn't?
Yeah. So we have, we have an AutoML engine. So we're creating your models. Those are registered in our repository. And then today we don't actually have the online store enabled in our open beta. We'll be enabling that at some point in the future. I would say probably like Q2 or Q3, we'll probably start to see.
This question from Mike is about serving of models, so deploying models over the network, in serving infrastructure. So he's saying, when you're auto updating models, how can you ensure that the models still perform as desired? What safeguards can be configured to prevent a new model version from going live? Yeah, so in our system, even on the batch case, we have a concept of what is your promotion criteria. It doesn't really matter if you're batch or real time, but like if I'm training a new model, I can look at that model and I can understand, like, let's say root mean squared error is the performance metric that I'm interested in. Did this do better than the last one? If so, promote it. Or I could tell the system, always promote the new model. I don't care how well it performs because I know the data has changed such that the old model is now invalid. Or I could do something like say, don't ever promote a new model. I want a data scientist to go in and do a manual inspection of it. And then like they'll schedule a promotion or something. Sure. So I think, as a good ML system, we'll be able to handle a variety of use cases around, model promotion. And even if you're using AutoML, you're not necessarily like auto promoting everything. And I feel like the auto promotion is often what people are afraid of, which is like, oh, I created a new model and like it just automatically took over prod. So, having that framework where you could either kind of instruct the system what decisions to make during an auto promotion, or just say like, don't ever auto promote, like we're gonna have someone look at it and they have to sign off on it. I think we're gonna end up with an MLOps, DevOps style environment where when you've trained a model, you'll have to have many different slices of data representing the different potential people who'd be disadvantaged by it. And there won't be one score in your model. It'll be score for all of these groups, and then a bunch of boxes to tick if you're gonna pass the because legislation's coming, right? We have legislation.
Oh yeah, exactly.
And if you don't have that in place, that compliance layer, I think it's going to be tough.
Right. And I also think that, things like bias, you have to start looking at. You need platforms that understand bias and can account for that. But, I think a lot of the explainability stuff, you can also automate that. So, going back to like, what does a data scientist do? In my vision, I think, you could let a data engineer control the process. Everything gets automated, including the things the data scientist wants to look at. So they just log into the platform and they're like, all right, I know we're checking bias across these 3 features. What are the bias scores for the new model? How do those compare for the old ones? So just like make their job as easy as possible so they can come in, make very quick decisions, and not have to like get like super hands-on with the data to like calculate all these things by hand.
Cool. Last question. It can be a quick answer because we're out of time. Constantine asks, do you treat embeddings different from raw data?
Yeah, that's a more complicated one. I would say potentially yes, but that kind of gets down into the weeds.
It's a good answer. Yeah, I mean, we treat it as an array of floats, like an array of doubles or floats, basically, and then you've metadata around it, basically identifying this as an embedding. Okay, great. Thanks, Jordan. And Natalia, any words before we say bye?
No, thank you. It was a very interesting presentation, Jordan. Just a quick reminder, we'll be sharing the slides and the video from Jordan's presentation on the Slack. So make sure you join. The link is on the chat. So stay tuned. We have very interesting presentations coming up next month, including MasterCard. So
great. And try and give it a spin continually so you can get your hands on and dirty. It's really cool. Thanks, Jordan. All the best, everyone. Thanks everyone for attending, and hope to see you at the next one. Bye.
Thanks for having me.